So let's get started. So this webinar has been designed considering college students in mind. So this will not be really going into much details about any individual topic, but we'll be covering some of the basic fundamentals considering students in mind. So we will be talking about what automation is. Then we will be talking about some of the basics of robotics. And then we will talk about Industry 4.0. That's what are the new advancements that are happening in this field. And then we would end it up by going over the job profiles and what you can see yourself and where you can see yourself. Most of you might have seen this slide in the past. It talks about the revolution that's happening in the industry of factory automation. So right now, most of the factories all around the world are in the phase of Industry 3.0, and they are shifting to 4.0. What do I mean by this? So right now, most of the factories are automated to the extent it can by using machinery as well as computers and robots. But the problem with the machines at the factories right now is that they are working in silos. So they are disconnected with the rest of the world. They just work independently like a machine. It's more like a smartphone in your hand without internet connection. So that's how the industry is right now. And the reason it has been in this way for probably last decade or so is that the industry people feel threatened when if they want to connect it to the internet, because they are always worried about the privacy of their data and the secrecy of the work that they do. But with the advancements in the security through softwares and other features, now the entire industry is more confident. And so the factories are shifting to the Industry 4.0. That's about making their factories smarter. When I say smarter, it's about connecting all the machines to the internet and Internet of Things. And it's all about connectivity and making it a part of the global system. So let's get started with the basics. What is automation? If you see the picture on my bottom left, what you see is a box that has to be shifted from right side to the left side. And generally you will have an operator doing this. If you replace it with a robot or a machine to do this work without human intervention, automatically all the time, continuously, without any break, then that's what you mean by automating it. It's about shifting it to a phenomenon where it's being done without human intervention. I have a couple of examples here about automation. The one on the left talks about refinery automation. It can be an example of probably oil industry or some chemicals or petroleum or any other thing, like even probably medical. So it's about you have some liquids that has to go through a process. It goes from one location to the other, and you have sensors and valves which are controlled remotely through a computer, and everything is run through the computer in a control room. So that's one type of an automation that you would see. On the right side, what you see is a factory automation that you probably see more on the TV and in the news and media, where you are probably using a robot or some other device for handling and doing some action, which is decreasing the use and the requirement of human intervention. So this presentation would be focusing more on the one that you see on the right side, that's factory automation. So again, in factory automation, you might have an option wherein you might go with semi-automatic, the one that you see on the left, wherein you still need human intervention, but the machine is going to help you in making it simpler and faster. On the other side, right side, you see a fully automatic solution where you have robots doing the work and you don't need human intervention. So when the question that would come to everyone is, when you have the right one where you can do everything automatic, what is the need for semi-automatic? There would be instances wherein it probably makes more financial sense to go with semi-automatic than automatic because of the complexity that is involved, which would drastically increase the cost. So now we will go to look at why we need to automate. So the first and foremost thing that motivates companies to go for automation is decrease in cost. Because for a company, it's all about making profits. And so that's the major factor. Then comes shortage of labor. Yeah, I know most of you are thinking, what do you really mean by shortage of labor? In the Western world, there are a lot of countries where you have a shortage of labor. So it makes sense for those countries to go with automation. And the third point is about increase in quality and repeatability. Let's take an example of a welding application that you need to do for a car part. If you have an operator doing the welding, there's a high possibility that his hands will not go through the same repetitive path every time he's welding a new part. Or probably there might be a different operator as it shifts from one shift to the other, which is going to change the way he's going to weld the part. So the quality is dependent on the person and probably even on his mood. You don't want that to happen. And so in those cases where quality is higher priority, you would go with an automated solution so that there is repeatability in quality. The fourth point is talking about human ergonomics and safety. Let's take an example of painting the parts of a car. You might have seen videos wherein a car goes through a tunnel where there are robots on both sides which are doing the spray painting. Why do you need the robot to do that instead of an operator? That's because there would be a lot of harmful chemicals when you are spraying the paint, and that is not safe for the human operators. And for factories, human safety is one of the most important things. And so for those reasons, it makes sense to go with automation. Even if it doesn't make sense from economic perspective, probably in some cases, they would still go for it because of the safety. Then the next point that I have here is talking about hygiene. Let's take an example of probably what is happening now in the last 1.5 years after the COVID got started. Everyone is more and more cautious about health and safety. And let's say there are factories which make food that we eat as well as medicines that we consume. So if at all you have an operator who is sick and he is standing in front of the machine or he's doing some work there, there's a high possibility that some bacteria from him might get into the food that you will be consuming later on. So factories and companies don't want that to happen. So that would be another reason why you might go to automate the process, even though it might not make cost sense, so that you decrease or almost eliminate the possibility of contamination due to human intervention. The last one, I'm talking about marketing. So you might have seen some videos on YouTube or somewhere else where you might have seen people sitting in restaurants where you have conveyors bringing the food onto the table or something fancy like that. What is being done there? It's not that you don't have people to serve you the food, or there is a shortage of people. It's just about using the technology, showcasing the technology to make it more fancy as a marketing tool to attract people to their stores or shops. Now, as I was telling you that the first point, which is decrease in cost, is the most important thing since it plays a big role for all the factories. So it is one of the major factors that is calculated is ROI, that's return on investment. So let's take an example of gym. He is a manager in a factory, and he has been given a target for the year to decrease the overall cost that is being spent on manufacturing. So what would he do? He probably finds out that there is a solution in terms of a simple, cost-effective robotic cell that might cost probably $60,000. And he knows that the average salary of an operator, if he wants to have an operator to do this, to operate this machine, it is going to cost $40,000. So what is ROI? So if he replaces the solution with a robotic cell, then within 1.5 years, he's getting back the money that he has invested. So that's a very good number in terms of ROI, and that's a win-win situation for him. And that is a business case that he would be presenting it to his management to make the cell automated. See, this example that I gave was not considering into a lot of more details. It is just for you to understand the basic fundamentals here. Now, let's look at some examples and applications. Let's say there's a factory where there are 3 machines which are cutting and drilling onto some parts. So since there are 3 machines, you would need 3 operators. What will the operator be doing? He'll be picking up the red part from a conveyor, bringing it, loading it into the machine. When it's done, he'll pick up the finished part, put it back onto the conveyor, pick up the next one, and keep doing the same again and again. So that's what he would be doing, a repetitive task. So what can be a solution in those cases? The solution would be a cost-effective solution is a gantry. What you see here, the horizontal purple and the vertical yellow, is a solution that you can provide, which would automatically come down at the left side, pick the part, load it onto the machines, and unload when they are done. So once you put this into the factory, boom, it works 24/7 without a break. So that would be an advantage for the factory that is producing it. So you see an example on the right side where you have this overhead system that is loading and unloading machines. So this is one of the common solutions that you provide for automating something. See, the type of machines that you provide for automation would vary based on your application. It is not the same solution. You have to look at this application and then define what is the right solution for it. Now let's talk about robots. Where does first robot come into? Robots are more like a subsection within the field of automation. You might have a gantry as a solution, or you might have a robot as a solution. And there would be probably more things that you might provide a solution as a solution to the application. So robot is a product. I am specifying on the word product. When you say product, you design it without considering the end customer in mind. You will not be looking at what the customer is going to do with it. You just design it so that it can be used in multiple ways and locations. So what are the major parts of the robot? In the middle, what you see is what you generally think about when you think about a robot, industrial robot. That's a manipulator, the mechanical device. On the left, what you see is the heart or the controller, more like the CPU of your old traditional computer that you used to have. And on the right side, what you have is a teach pendant, which is a touch screen, which helps you in moving the robot around, as well as in programming. So this is sold by a few companies as a standard product, which is later on improved to make it as a full-fledged solution based on the customer needs. So when you look at the companies that provide robots, the first 4 that I have here in the list, ABB, Yaskawa, KUKA, and Kawasaki. These are the major big players in the world who have been in this field from a long time. And there are a lot more, as you see in the list. So now let us look at an application where you will be using a robot. What you see here is more like the previous example I have given, where you are loading and unloading the machines, but the machines are placed in a different configuration and you have the robot in the middle. So you have parts, which are the red ones coming in on a conveyor. The robot would pick them up, place it into the machines, load, unload, and when the finished part is put onto this outfeed and it goes outside. So this can be one of the typical solutions that you would provide based on the customer needs. So again, I repeat, this robot is a standard product. You would be providing a customized end of arm tool based on the application. And you would provide a full-fledged solution like this based on the customer needs and the space he has and based on his production rate. Now let's talk about safety. See, safety plays a very, very important role in any factory. When you are probably walking on the street and when you look in general about India, you would come to a general conclusion that safety isn't that big a deal in general. But when you go into a factory, it is very important for the reason being, it defines the image of the organization. Let's say you are working in a multinational company which has factories all around the world. Even one small injury to one operator would have a huge consequences. It would be, the news would spread like anything all over the world saying that the factory is not safe there, and it would have huge repercussions. It's more like probably if you find an insect in a cool drink and the news gets spread like wildfire. What happens to it if you find an insect in the bottle that you have in your hand? It drastically impacts the image of the brand. So it's in a similar way, it has a huge impact on the organizations. So factories give topmost importance to safety. And when we talk about robot is a device that does the work automatically, continuously, without any break, without thinking about humans intervention. So if what you see here is an application wherein you have 3 pallets. Pallet means a wooden, probably a rectangle, square, 150 mm tall part, onto which, let's say, you have boxes coming into the cell of different variant sizes. So the robot has to pick the red boxes here and stack them in an order on this wooden pallet. And after that, the operator removes this and takes it to the storage area and replaces it with a new one. So when he is doing that, you know that the operator is going to walk in and out of the cell. But robot, if at all you don't think about the safety, the robot will never know that someone has walked in. And for some reason, if he walks onto this side and stands here, the robot is not going to know that. And it is going to injure the operator. You don't want that to happen. So when a company is providing a solution as a robotic cell or any machine, the topmost priority for them is not just to make this workable all the time, but also ensure it is the safest solution you are providing to the customer. So what you see here is a light curtain, the red line. It is an invisible beam that will be across the cell in the open area. So if someone walks in, this beam will get cut. So the controller or the brain of the cell will come to know that someone is walking in, and the robot would immediately stop. It's like an emergency stop. Within a fraction of a second, it would stop. And when he's done with his work and he walks out, he needs to again reset and press a start so that he acknowledges the robot saying that it's ready to go, good to go, and everything is fine. There can be also instances wherein someone wants to play with a robot and do something stupid. So there can be an instance wherein an operator is probably standing inside here because he wants to probably check something. He probably might be having some good intentions. So he might be standing here and he might ask his colleague to press the restart button and press the start button. So the robot will not know that he's standing inside, and it would start working around again, which again has a potential of creating a safety hazard. So what you will also provide is an area scanner. So this, what it does is provides a huge beam of rays all over, more like a sci-fi movie, which is continuously scanning the area to ensure there is nothing beyond what is already defined in terms of the mechanical things that are sitting on the floor. If there's an operator standing here, it would know that, and it will not allow the robot to move forward. Let's talk about another instance. There's a mechanic who wants to walk in and fix something here, and he is not sure, or he has to ensure that no one else comes in and presses the start button when he's standing inside here. So he wants to be safe. The procedure for him would be that he would open the gate at the bottom, which would have some sensors here. So the moment he opens it, it would know that it has been opened, and the robot and everything will stop. He would have a key with him that's again connected to electronics and devices that is telling that the cell is opened and is there someone who is entering inside. So as long as he doesn't come out, close his door, put the key back, the robot will not start. So he knows about this, and he will feel safe, and he's good to go, and he can do what he wants to do in terms of fixing something. So what I gave you now as an example is some of the things that you would be considering from the safety perspective when you are designing a cell, a robotic cell, or probably any other machine, whatever application it is for. So you don't just make a machine to do its work, but you also design the machine in such a way that it ensures the topmost safety of the people around it.